What's up, solderers? So, we have completed our circuit as per our last video, and now we are going to plug it up to some sort of power supply system. So, let's talk about that. If we can see over here, we know that this over here, this component over here, is the way that we're going to be putting power into our system. We can see that we have a positive and a negative sign. The more important thing is, if I can get that angle right for you, because that one is upside down for me. There you go. So we can see there that according to this circuit, DC 2 to 12V. So that's obviously the voltage. So DC meaning that we need some sort of battery or a constant power supply to do this. Practicalities for you setting this up at home. A 9-volt battery perfectly would fit this range. A single AA battery will not, because they're typically around 1.5 volts. So you need two of those together plugged in series. So if you have a battery supply that has that, if you have a USB power bank or power supply that you're able to get voltage from, that would work, because USB is at 5 volts. I have the laboratory power supply that we have running at the workshop. I brought one of those home. But a more general case, if you just get a 9-volt battery, you can get it and you can just connect the wires. You might have to solder additional wires, so you can actually solder a wire from these 2 points here, so you can have 2 wires coming out and connecting to your circuit. So how I do it, I have these 2 plugs over here which are connected to my, look at the mini screen over here. I have the power supply over there. I'm not going to bother refocusing because it takes too long, but I have the power supply here and we see it's plugged in. I can adjust my voltage. So I'm going to get my volt, and I'm going to show different voltages and how that affects the circuit. But these are 2 clips. Where are you? There you are. These are 2 clips, and these clips are actually kind of big. First time I tried to plug them in, right, I plugged in these 2 clips to these points over here. The problem we had is it was very difficult for me to get a connection with these 2 clips and to prevent them from touching each other, because they ended up touching each other and it created short circuits and it wasn't ideal. So I also had to find a way to connect it. So these over here are connectors. The reason why we use connectors such as these is so we can have like a terminal. We can have this cable over here. This can be plugged to our battery, and we can just plug this in, so we don't have to constantly be soldering or resoldering our clips. So I got these. These are just the sockets, right, that are designed to go into this type of plug here. And I deliberately picked this color combination because it's going to help us. If we see by our power cable that I have here, I have red and black. Now if I go all the way to, I'm not going to move my camera, but plug into the power supply, the red is connected to our positive source and our black is connected to our negative source. We use this so it's easy for us to know if we always do this type of connection idea or protocol, it's going to be easier for us to remember what cable is what. So in general, you always want your black to be your negative and you always want your red to be your positive. So over here I have a black and white cable, so I'm going to make sure that the black is plugged up to the negative, and so then I know by association that the white will be connected to the positive. So I'm just going to plug those in. Now I'm just going to plug those in there so we can see I have the 2 table. I have the black and white and the E. There we go. And the black is plugged up to the negative. There you go, all in one camera. So then I'm just going to get this cable from this end over here, and I'm going to plug the negative up to this end and the positive up to this end. So if you plug this straight up into your, if you had this plugged into your 9-volt battery, you should already be seeing some cool stuff happening now. Now I'm going to turn on my power supply. It does have a fan, and I haven't tested what the sound is like, so there might be a bit of a sound issue, but I'll have to test the video after. We'll see that. But let's do it live. Right, so I turn on my system. It has. I'm going to turn off my headlights so we can get more realistic color. And let me start. I'm going to start pumping up the voltage. So right now I'm at 0 volts. And as I start pump, actually, can I get the camera to be focused on the voltage so we can see? Oh, there we go. Pro streaming setup. We also have current, but I'll get to that later. Actually, I'll do both. Can I do both? Nah, it's too much. Let's just do voltage and I'll move it over. So right now we have that. As I'm adjusting the voltage up, we can see on the main camera, we have really nothing happening. But once we get to a certain voltage, I'm here at like 9 volts. We're clearly seeing that we have some sort of a light flashing color combination. Right, and so this is it's spinning around. It's a good sort of idea to have here. It looks kind of nice. When I first tested this, I've seen other circuits that the lights have been flashing a lot brighter. Because it seems like it does flash depending on different values. Like the LEDs themselves are not the best, and some of them might be creating like issues. Like for example, this light over here looks to be the weakest out of all of them, and I might actually replace this light because all the rest of the lights seem to be flashing fine, except this one over here doesn't seem to be flashing much. So I'm actually going to replace this one in our experiment when I'm teaching you how to replace electronic components. So I'll make sure this is the one that I damage, per se. But in our system, we have our lights flashing, and everything looks good, right? It goes in a circle. Now let's see what happens so we have the lights flashing. Now obviously we can assume as I change the voltage, the intensity of the lights should go down. Right, this all makes sense. Oh, what happened there? The intensity of the lights should go down. Now this all makes sense, right? But as we know, the actual intensity of the voltage also changes some other factors, like the lights they're flashing fully for whatever reason, but also it changes the rates that the lights are rotating. So the actual voltage and the current going into the system is changing the way that the capacitors are lighting up, and the rate that the capacitors are lighting up is changing how long before those transistors are like loading up the new circuit. So our voltage is changing more than just the power of the lights. And as what I've found in general, oh, that looks much better. In general, as you put more voltage in, it rotates faster. So I'm imagining the capacitors are charging themselves faster, which means they're activating the next transistor. And when you go lower, right, you have the intensities reduced. But it also rotates at a slower rate. So this is a very simple circuit. It's not very smart in the sense of like knowing when to switch. It relies on using like an interaction between the transistors and the capacitors, in that as one transistor allows the flow of the power through one of the lights, it drains one of the capacitors, which activates the next transistor, and as that one drains its capacitor, activates the next transistor. So it relies on the interaction between these transistors and the capacitors, and actually having the one transistor that's the different one is what allows us to get this rotation happening with our flashing. Yeah, so that's our circuit. Let's see if we can play around with any other things. So if we go up to 12 volts, see that should be the fastest it's rotating as possible. It looks almost looks like it's almost organized, but it does look like it's flashing at a weird rate. So I will change this light over here, but everything else seems fine. I don't think there's any problems with short circuiting, apart from the one I mentioned before with the cable that when I was plugging in the power cables. I'm just going to turn the power off now, so if the fan was a problem, it's not the largest problem. Oh, no, I will turn it back on for one more reason. So as we put our voltage in, so we go to 10 volts, we see our amperage over here. So that's at a low amperage. That's if that's 1 amp, That's what, less than 0.1 of an amp. And I'm changing the voltage between, right now it's at about 4, and I'm going up to, and this is at 12. We see the voltage, the amperage changes slightly. So that's the amount of power going, depending on the voltage I put in, depends on the amount of amperage that's going through our system. But that should make sense, because we know that our all our electrical rules follow the Ohm's law, which is the voltage equals resistance times current. And if the resistance of the circuit is common, the resistance of the circuit can't change because we have those resistors in there that we've measured before. They don't change in the grand scheme of things. Like, obviously they change by temperature and stuff, but in general their resistance is constant. So if we're increasing the voltage, we should be seeing a change in amperage. So it's good to know that our circuit is following the laws of physics, and that's a good sign. Right, turn the power off, amperage goes down. So, which one is the actual bad one? This one. I'm going to mark it. Where is my pen? Huh. I have lost my pen to mark my thing. That's disappointing. Oh, it will show up at some point when it wants to. So let's just mark. This is the LED that we're going to change. Just marking it so I know this is the one. And then I'm going to turn off the power so we can mess around with that LED, because we know it's the one that is the least performing out of all of them. Cool. Alright, so we're going to move our power. I still have my soldering iron turned on, so it's still a safety thing. Let's bring the... Oh, that was almost a face reveal. And let's get light. Okay, so this is the LED we don't want. We have a backup pen. This is the LED we want to get rid of, so let's just do an X mark on it so we don't remove the wrong LED. And let's try an example of over soldering. So we're going to do so much solder that it's going to create a short circuit in this LED, and then we're going to show the basic way to get rid of that with a with a desolderer. But then we'll also show some other methods of using like wires and such to fix the soldering. So we have this piece over here. We're putting in our solder. This all makes sense. There we go. Just to confirm that is the one. Yes. I'm going to bend this leg so we know that that's the one. Okay. So we're putting in so much solder now. Come on. Sometimes it's actually difficult to make the mistake. So there we go. I think we can all agree that that over there is a short-circuiting problem, and that one is definitely not going to light up now if we tried it. So the easiest and most efficient way is using one of these devices, which is a solder sucker. All right, it works. It works by, if you push down this lever over here, right? It has like a cylinder in here, so the piston's down here, and a spring. And so when I push this button, the piston is going to move to the top, which is going to create a vacuum inside here, and it's going to suck in whatever's on this side over here by pressing that button. Now the reason we do this is because when we have the solder's obviously solid when it's not heated up, so we have to heat it up and we have to rapidly move it while it is still in liquid form. So that's why we use our solder sucker. So I'm going to prime our solder sucker. I'm going to heat up our solder. Put the solder sucker as close as, I'm going to get a good screen size over there. So go back to the ruined location. So I'm going to have the solder over here. Bring the solder sucker as close as possible and press it, and it should suck some of the solder out. And then as you extract it, the little pieces of solder come out. So because that wasn't the best example, I'm just going to, let's look at the scenario where you put too much solder into like a single piece. Like, oh boy, there we go. It's like big chungus of solder over there. So this thing over here, we have to heat it up, right? And it's going to be hard to get rid of. I'm there lifting it up with my soldering iron, and it's not disappearing. So again, I'm going to prime my soldering iron, heat it up, and then put the solder sucker as close as possible. Press it. It should get rid of. It should assist you in getting rid of the solder. Now, it's all about getting that good angle. And when you release the soldering sucker, you have to push it out. As you push it out, you see this piece of metal that sticks out. Solder will often get sucked in and will stick to the inside of the syringe. And so you have to extend the soldering syringe all the way, and it's going to push out the solder from the solder sucker. But now I want to replace this component over here, so I need to actually do more of it now. I'm going to try to remove as much solder from here as possible. It's going to make my life easier. So again, I'm going to heat it up. I'm going to get the solder sucker right close and keep sucking it in. And we see there now there's less on that. Which one is it? This one. You can clearly see this one has less solder on it now. And I'm going to do it with his buddy next to him. So it looks like that's the most that I can get out of it. So now to actually remove the component, this is the part that is let's see if I can show you the way how to remove it with without access to a solder sucker. So obviously a solder sucker is ideal. The other thing you can use is a solder wick. You can buy those. They look like a piece of they have a piece, they're like copper, like the copper inside wires, but they're like wound in a certain way, so they like absorb. They allow, as they heat up, the solder's going to want to attach to the inside of the wick. So that's how they work. Now what I'm doing here is I'm getting a wire, right, a standard wire, and I'm getting exposed parts. And now I'm going to try to wind them up in a way so they're all like exposed. And so over here I have a whole bunch of wires in an exposed way, and as I heat up this piece here, I'm going to try to heat up the wire as well. And so I want the solder to detach from the light, and it's going to want to attach to this wire. Now I do have to make sure as I'm doing this that I don't actually solder the wire to my component, because that is not what I want to do. So let's So in this particular case, I'm trying to heat up the wire instead of heating up the component, because remember how we were saying that you want to heat up your copper and you want to heat up your soldering component so it will actually melt the solder. And so I'm doing that same thing there. Don't know if we got that on camera or not, but I did that, and if we see here, there's a solder is on my wire, and there's less of it on the component. Like that one's nearly stripped clean. And I'm going to do the same thing to the one next to it. So you're going to try to want to use a clean piece, because like again, you don't want to melt the solder that you just spent all the time removing. Now, all this stuff where you're repairing your circuit, it is the highest level of difficulty because you're doing stuff that is unideal. Solder wants to attach to stuff, but so we have to like understand that it can't always be perfect. But as we see there, we have removed most of the solder. So can we get the solder completely out of the system? No, we cannot. So to actually remove this component completely, what we're going to do is we're going to cut it short. Again, I'm wearing safety goggles, so little pieces don't get me. I'm going to get my solder sucker, and if I actually heat up the circuit, if I give it a lot of heat, I can actually get my solder sucker like right on top of the component. Ooh, that's a good one. Do we see that? See how this component over here has nearly all the solder removed, that you can actually start to see the you can see the gap between the component and the base of the circuit board, because I got my solder sucker really close to the component. You're going to do the same thing with your wick, is a bit more difficult. Alright, so now I have removed most of the solder from this part. So if I try to wiggle it from the top, it's actually, you can see here that it's actually loose. It's like a, you know when your tooth is like almost loose, how it's released on one side. That's what this feels like right now. So this, I can tell from the way I can tell by the way it's shaking that this part over here is completely disconnected, but this one is not. This one still has, and if I zoom in with my eyes, I can see that it's still got a slight bit of connection on this side over here. So let me see if I can just remove that part. Or once I know it's removed from one side, I should be able to heat it and just push it through. So I just provide heated, and as I was heating it up, I was pushing it with the soldering iron. You can do that once it's like near the end, and now I've removed this LED light. So let's try to replace that light with another one. We'll just put in another light, and then we'll go through and we'll do our soldering. Cool. Give that a... I shouldn't have blown on it. That was bad. I would lose marks. But that was a bad habit that we got to move on from. Anyway, so let's plug this up. Let's see if that made any difference to our circuit. Let's plug in our power. Oop. Well, why is this circuit not working? Where's that black line? That black line is plugged into the positive. So I made a mistake again. Have it around the wrong way. So that's why I should have followed my own rules and followed my own color coordinations. Now when I plug this in, we should get... there we go. We have lights, and that light that we replaced... Well, I think they are all moving to what I'd consider to be the correct amount. Obviously this is a situation where it's more difficult for the camera to pick up, but it looks like all the lights are shining at an acceptable uh, level. Oh, very well. Okay, let's now destroy this circuit. Let's create an actual soldering catastrophe on one of the components. Let's say, what component do I want to break? Okay, I'm going to deliberately try to see this component over here. I'm going to try to put so much heat onto this component to see if I can ruin it. Right, I'm going to try to ruin that component by just absent-minding, like say I have my solder and I'm not paying attention, I'm looking around the room, I'm talking about like, I don't know, Pokemon or something else, and I'm just completely distracted and I'm putting too much heat into the system. And we'll see if, even if I can make a mistake, who knows, maybe I'm just so good at soldering that the solder itself will defy the rules just so it doesn't make a mistake in this system. I don't think it wants to make a mistake. Let's go real crazy. Let's say if I bump up the temperature to the highest level, we'll see if that changes it. Just letting my soldering iron heat up to its highest value. This could be a legitimate issue if you are using soldering irons that don't have like a temperature regulator. They're going to be going at their full power. Uh, okay. Oh boy. Oh, I can smell there's something up with that. So that there clearly looks like it clearly looks like we can see the burning marks there around that solder. So the actual solder itself may have actually disconnected from the board. Now let's also imagine, as we did that, it actually broke the circuit, right? So the copper track was actually broken. So where I'm putting my soldering iron, like it's not connected. Right? We would have to find a way to connect this cable to something else. Right? And this happens to a lot of students, so it's going to be worth us doing a practice of. Oh, that is very hot. So let me get out a pointing device. So over here we have, right, this is that part. It's connected to this green line over here. What we're going to do is we're going to follow this green line. Right, it's this green line over here. We're going to follow this line and seeing where this line connects to another component. Right. Let me, so this is the green line over here. If we follow this green line, we can see, once I get around that stuff, there's still this line over here. It's going to connect to this. Alright, so we can see there's a direct line. It's like following those maze puzzles that you see. So this line goes over there. It also goes, well, it goes to a lot of components actually, which makes sense if you think about it, because we had 5 lights at once lit on every single. So it's a series of 5 lights all on at the same time. So this thing over here is obviously all connected to the same source at some point to tell all those 5 lights to shine. So I've got to choose which one I want to connect it to. Let's say I want to connect it to something that has a nice big terminal. So I'm going to connect I'm going to connect this light following the track, and if I follow the track it goes to this point over here. Will I be able to draw on the thing to assist you? Let's see, maybe I need a... I think I've got a text to type. There we go. Alright, so I'm actually going to physically draw it on the track for you. So if we have this over here, goes down here. See that texture mark? Ugh. Look, it's not my best drawing, alright, but I think you can get the idea, and I think obviously if you're going to have mistakes on your own circuit, you're going to find them out yourself, and you'll have to design the best track. But we see those two are physically connected by the soldering cable. So if I heated up so much that I actually burnt the copper off the track, or the part was broken, I would have to make a manual link between those two components. So to do that, you're going to need some wire. Right, let's get an approximate length of wire. So we want the length of the connection, and then we'll add like an extra, I don't know, an extra 2 centimeters on each side. We'll get extra, and then so it's going to be easy for us to work with it later. Use your method of cutting soldering cables. Like we know we have cutting wires. We know we have I have the high-tech Tyrannosaurus Rex pliers. You can use cutters. You know, I'll show the worst case scenario. Say you have scissors. As you're doing it, right, you don't want to cut all the way through. You just want to put enough pressure on the outside, and then I'm rotating it. Right, so I'm putting just enough pressure on the outside. So I just want to do all slight cuts on this, and I'm just trying to remove the outer layer of plastic. And then if I pull, there you go. See how I already have that thing coming off? So, and then I can pull it all off. And so now I have two exposed pieces of wires. I'm then going to hold onto the metal and then twist the thing, which means that now we have a nice looking braided wire. It looks nice and neat, as opposed to these ones over here when it's all straight. When I try to push it through holes or try to wrap it around, we're going to get random pieces coming out. So I always like to just twist my wires to be nice and neat. So to actually solder this, so now we have the extra level of difficulty when it comes to soldering, because we have to have the dexterity of holding the solder and the wires at the same time. It is probably the more difficult part. We can actually make our life slightly easier by, instead of soldering onto the component first, we will attach the solder to the wire itself. So I'm just going to get some sort of device to elevate up my wire so we can see it. There we go. Alright, if we just get our wire, we can attach the solder to the wire first, and same thing, we're just going to heat up the wire. Now the wires could take more than 3 seconds, because heating up an object depends on the density, like the weight of the object, because it's got to heat up all the atoms in it. And a piece of wire typically can have more parts than an electrical component. Sorry, more metal. So then the whole wire will tend to heat up, so it's going to be more difficult to attach the solder to it. But then here we have the solder. Let's just make sure it's actually attached to the wire, which that's what it looks like. Yep, and then I'm just going to clean. And I think that is a good enough piece. It's not the prettiest, but also these wires are not, this is a tin-based wire, and it's not copper. I would prefer copper. If you have copper wires, use them. They are the best. These are like non-rust, so they're metal. I think they're tin, but they're something silver color, so they're not the ideal wires. But it's all what I had access to. So same thing. I'm heating up the wire itself, and then the wire, as it heats up, is going to get the solder to melt and attach to it, if all goes well. All right. So now I have my solder onto my wire. Before you grab the wire, be cautious, because the whole wire itself would have heated up. If we actually look over here, the wire itself has actually had some melting because I've heated it up, and which makes sense, right? The wire itself is not heat resistant to the fact of like a soldering iron will melt through the wire. So we have to be careful when we grab our wire that we know that there could still be some residual heat into it. Right, so let's say we have this issue over here. We're going to get that wire. Depending on, like, you're going to change every case is like a custom case because you're obviously connecting your mistakes to something else. So sometimes you're going to be able to like bend the wire into a U shape and get it around the object. We want to make sure that we do not short circuit it because we have a large wire coming out, so we want to just keep that in mind. Let's see if the solder we have on the system is enough to actually attach it to the object, and it looks like it is. Oh, that's getting very close to the other side of the soldering line, so let me just adjust the other side of the LED. And there we go, that looks like that's in place, and that's connected. So one part done, and I can tell it's good enough because I'm able to hold it up by that. So the next part I have to connect is the other part of the circuit. I'm going to link it up like this. Right, I linked this part over here. And if I heat that up, let's see if that works. There we go. So now, this circuit, if either one of those two were broken, so let's say this case was broken, where I'm pointing over here, if this part over here was broken with connection to the circuit board, I've now manually connected another wire to connect those two parts together. And so you're going to go through this, and when you see an error on your circuit, when you're doing your testing, or when you're just inspecting your soldering and you're seeing that there's issues, like you're seeing the metal lifting up in certain areas, you're going to create this your own version of these hookup wires. And I believe that is it for this circuit and testing. Oh, the last part we're going to do is clean it up and make it all pretty by removing all these pieces. I'm not going to. I don't have an Instagram yet. Oh, we have pieces flying everywhere. Yeah, so when it comes to cutting these parts, definitely this is a part where you need your safety goggles on. You can also, so when I had these pieces over here, depending on what cutting device, if you cut it with enough force, it's going to fly. You saw that one, it landed like over here. You're going to get these things flying around the room, and like this is essentially a pin for all intents and purposes. This over here is a pin. If this lands on someone, if someone steps on this and it's like, if it's especially if you have like carpet and it lodges it up at like an angle, this can go into somebody and it could cause actual serious problems. Like if you're lucky, you can pull it out by hand or with a tweezer. If you're unlucky and like it gets deep inside the skin, you will have to go to a hospital to get that out. So when you're actually cutting these components, a safe way to stop it jumping around would be to like you can have your finger on the other end of the component, and so it's going to just let it get cut in place. So for example, I have this component over here that I'm going to have my finger on. So when I cut it, right, it just falls down because my finger's stopping it from jumping out in the other area. It's not that there's a lot of force on it when you cut it, but the components are so light that the force of the snapping part like shoots it forwards and across the room. So we just want to be generally careful with this stuff. And it happens the worst with the stiff components, like these LED lights are probably the worst because I think they're the thickest, apart from the connector, but we're not cutting the connector. Then we have our capacitors. And last we have our transistors. Alright, so there we have our nice flat circuit board. Means we can have it down low onto a surface. We have to get rid of all these individual components, but I'll do that later. I want to see this thing light up. And then we can also test if when I removed that light, if the jumper cable actually worked. So, hey, circuit's working. The lights look, actually they look really nice now. Maybe removing those cables, maybe there was some sort of a short circuit that I was seeing. I have noticed that the actual way that the lights work change depending on when you're first putting in power into something, into the system, or when you're not. So I'm suspecting that it has something to do with these capacitors. As you first start the system, the capacitors are charging up, and when they're first charging up, they work at a really good rate. Yeah, so when you first plug them in, they work really well. But then as the capacitors get charged, they relate to the I don't know, the transistors in like a weird way and produce some flashing anomalies. But overall, for a circuit that costs a reasonable amount of money, it still gives us very basic learning into components. And I will give us a lesson where I want to simulate this. Actually, that's what I'll do next lesson. I'm going to show us how to do simulations, and so we can see how the system is actually working. Alright, thank you, and good luck with your own soldering.